Thank you, Chair, for inviting me to give you this keynote. It's a pleasure for me to have a so qualified and large audience in the International Conference on Web Research. So I am going to talk you about the activity that we have done to enable decision support in Smart City and Industry 4.0, mainly exploiting big data analytics and IoT. So in the past year, we had experience in many cities the development of vertical applications. So in most cases, a lot of offers and solutions were implemented for addressing single services, such as the waste management or the smart light management as a vertical. And this vertical are based on some data interface for acquiring data from the field, some data analytics and dashboard. In some cases, there are also solutions for billing, for instance, for the smart bike or car sharing and so on. In other cases, the billing is not so relevant because it's a service offered by the municipality and billed in other ways or paid directly by the organization. So in this context, a number of organization and activity has been addressed by the European Commission to stimulate the analysis and identification of requirements. For instance, APE, SEC, the European Innovation Partnership for Smart City and Communities, and also the ENOL, the European Network on Living Labs, and exactly tuned on the Smart City. And Select4City was one of the largest pre-commercial procurement with Helsinki, Copenhagen, and Antwerp involved as a city to identify the best solution for putting together the smart city context and the living lab. So they identified a number of requirements for the smart city, for mainly focusing on creating city dashboard, not only for the decision support, but also for the operator and also for the city user in general, different kind of city users. And among these many requirements, there is the needs for addressing historical data together with the open data to provide the access through APIs or microservices to provide origin destination matrices, to have the possibilities of implementing data-driven real-time application using web interface and without the needs of installing in the local computer some application. So it was the moment in which the concept of IoT application, IoT edge, multiple operating system, and microservice have been were defined. So on this context, also data analytics is part of this game, because data analytics is the way in which the data collected on the server side are transformed and made available in the web interface, as well as the original data, and in a pervasive manner for the final user. In this context, the role of Living Lab is enable the usage of the platform and the development of the tools, and so for data processing, for data analytics, and also for visual analytics, so for representing data, all done on the web-based. So aside this number, with the large number of requirements that I just summarized in the previous slide, there are also a number of non-functional requirements, such as the open source or interoperability, that is one of the most relevant requirements, and also the possibility and the needs of scalable, robust, distributed, heterogeneous, and secure solution. Regarding the interoperability, the world of smart city and also the industry 4.0 is particularly complex because there are a number of data sources and data, let's say, data channels, not only sources on which the platform has to be connected. The brokers, the IoT brokers also communicate with the website, with the servers. The possibilities to make connection with the IoT edge, with making some web scraping, collecting data from satellite, connecting with the geographic information system, GIS, with the different protocols like WFS, WMS, connecting with the external services like gateway, and also connecting with the mobile phone that are a source of data for tracking people and collecting what the people would like to see, but also for receiving data, for receiving information from the platform. And also, obviously, linked data, linked open data are also relevant connection. The final aim is to integrate, aggregate this kind of heterogeneous data to have integrated representation and tools for decision support to be provided in some dashboard. So in terms of IoT, there are the Internet of Things, the Internet of Everything. So when you add also device, mobile device, and other kind of device, not only classical or small device. When you enter in the family of IoT, IoA protocols, a number of different communication patterns can be observed and provided by the device and the protocol standardization bodies. And the most common used protocols are the well-known MQTT or AMQP or COAP, and recently in GSI with the FireWire, and HC, and GSI is an HC protocol, and 1 and 2M, and an emerging protocol is also WebSocket. All of them are also on TCP/IP, and some of them are also on radio. Directly from gateways and brokers to the devices. Most of the IoT networks has a lot of aspect to do in the internet world. So this part is mainly on internet, while the below part with the dashed lines are radio protocols. So this means that in the web world, there are a lot of communication with their API REST among brokers and gateway, first level brokers, second level brokers, and also with the consumer of the data that are subscribed by some IoT application to receive the data and process this data inside some container, for instance, or some process. So in a so complex network is getting particular attention and relevance the creation of the IoT directories. So tools that allow to abstract from the physical position of the devices for the management of multi-tenancy or multi-services, and for discovering also the devices in the field according to some GPS position or some features that they may have, different protocols, different variables, different formats, and so on. So at the end, who is developing the IoT app, so the functional transformation for data, should not be bored with the details regarding the position of these devices in the network, because the positioning of the devices in the network at the end for who develop is just the coordinates, but for who is installing the device is a complex stuff, because it's obviously needs a standard authorization and special tools and special equipment for installation and so on. So most of the activity that we have done is not only for bringing data inside the storage that typically in our case is based on the coupling of a time series database like OpenSearch, that is Elasticsearch from AWS for time series, but also something like an RDF store for modeling the whole relationship that you may have in the city. So in terms of tripods. So at the end, you need to feed this information with the tripods and also time series. And this activity is performed through some adapters or special brokers directly from the real-time data coming from the devices, for instance. Recently, there is a strong push from FIWARE, for instance, for creating smart data models. Smart data models are, in substance, a schema, in this case, a JSON schema, for describing how the device mode could be according to some standards. So FIWARE has created more than 1,000 different smart data models for addressing almost all kinds of the smart device you have in mind, from waste to smart light for any environmental sensor, whatever. And this smart data model is a way to standardize the package and the information that is going to enter in the storage, in the data shadow, as is called in some other architectures such as AWS or Microsoft or others. So at the end, you need to have some brokers that could be managed by you, or that we call internal broker, or some external brokers or gateway that are managed by other organizations. And so you need some mechanism that I am not going to enter in this part to convert and understand which kind of messages are entering in your server, because the final end is to provide this information to your user through a web page with a nice visual analytics, with a nice dashboard to be immediately understood by the data consumer, the decision taker, the decision maker. So in this complex environment, there are, as mentioned by me before, there are a huge number of standards. If you would like to be interoperable, you need to be interoperable. You need to address a lot of these standards. They are grouped in IoT standards, and GSI, LoRa, LoRaWAN, MQTT, MQP, blah, blah, blah. So a lot of them. And some of them are specific for equipment, like Talk for Smart Light, or Alexa or DALI for some home application, and so on. And there are also standards regarding general communication at higher level. So HTTP, HTTPS, TLS for protection in general, they are RESTful. And but you may have special standards on top, like SOAP, WSDL, the web services, and FTP or WebSocket Secure, or other standards on top of this kind of layer. Formats, the most commonly used format presently is JSON or GeoJSON. XML is going to be abandoned, but most of those applications in the context of IoT, because JSON is easier probably, and so is commonly used also in JavaScript with most of the Node.js process, for instance, use this kind of approach. And also database, because sometimes you may need to access data directly to the database, and industry 4.0 standards for DCS, for distributed control system, are standard like OPC UA or Modbus or RS485. There are specific standards like DATEX or GTFS, DATEX for parking or connect and drive with a smart light or red light, and GTFS for modeling public transportation, and so on. So there are a very large amount of standards. The standards confusion or plethora of standards is not only the one problem. Another problem is the data coverage, data type. Data type is one of the most complex stuff because there is no IoT or point of interest. There are not only those information to be managed, but you have also to manage shapes. They can be modeled with some JSON in a shape model or other format, but there are other formats such as a GTFS again, that is a XML base, or GIS, Geographic Information System formats, like also GeoTIFF, heat maps, traffic flow. This is a traffic flow model. You see that is a graph with the segments changing value over time, and trajectories. You may have trajectories on the city. You may have 3D representation. You may have icons and that change their shape and color over time. You may have origin destination matrices. You may have prediction model, and all of them also synoptics. These are synoptics that are SVG typically with some interactive elements on top, and also visualization, dynamic visualization. You may have also beam model for 3D inside the building or the chemical plant or the plant in this case. You may have satellite data is another completely different format, and KPIs. So a large number of different formats, and most of them are so complex that cannot be communicated through an IoT device, for instance, and so you need to have other protocols. So behind this, there is the needs of putting together the relationship among all this kind of data. And for doing that, there are a number of knowledge base and ontology on which the data in the single instance are loaded, so that to create a real and actual knowledge base that you can query and you can navigate to understand what is going on, what is, for instance, what is the next stop at which you can buy milk. If you are on a bus and you would like to know, okay, where I should get down from my bus to buy a milk. And if you don't know where the bus passes, what is going on in the neighborhood of each bus stop from where you are up to the end of your ride, you need a lot of query. Today you cannot do on some Google interface, for instance, a so complex query that seems to be very simple and are simple done on a semantic database cannot be done from simple interfaces. So ontology are complex to be maintained, are complex to be defined, sometimes are not license-free, is also complexity in the usage of them. So, but the KM4City ontology that we defined and we distributed for free, license-free, is available for everybody. So in this context, another interesting aspect that is growing are the aspect related to the Industry 4.0, because the Industry 4.0 for many years they manage their activity inside the plant. Now many plants, many industrial plants are going to be connected together with some external connection, maybe with a VPN, and to exchange data and going in the direction of Industry 4.0 as a service, so such as decision support, higher level decision support as a service. In addition, inside most of the industry plant, also brokers are appearing for integrating some digital information coming from specific device that can glue what is going on in some part of your industry plant and another part to improve the automation, and also to make a strict connection for your administrative part and the decision support and the technical part. Because in most industry plant there is only there is no connection from the technical production side and the administrative. There is no connection apart from sending what has to be done in the next days, but there is no feedback, no direct loop in the decision support from the administrative database and KPIs towards the technical side. So the Industry 4.0 as a service that's passed through web application, obviously, and the web server in the cloud, that could be a private cloud or a public cloud as well, is appearing and is strongly requested. So another relevant requirements is regarding the security and privacy. Security and privacy, again, also pointed out by the HAPE or HANOL and Select4City, was to manage private data with public data. Obviously, if you put industry information, almost all data are private. But if you go in the city, you may have almost a mix of private and public data, because you navigate in the city and you produce private data with your positioning or your movement or the movement of some ambulance and so on are private data, while the context is typically created by public data. And in somehow it's possible to transform private data in collective data, so generalizing data with the typical trend or typical observation. And this is what Google make business, so that is a relevant business for many industry applications. So to understand how the city is used and to reuse this generic information to create valuable services for the common user. So what is relevant here is to protect the information and to protect the communication from at the different layer, for instance, from the device to the edge, and from the edge to the process on cloud, and also from the dashboard to the cloud. So all arrows that you see here at the end are needed to be protected by the attack, because most of these flows are passing through internet, and others are radio, like this one is maybe radio protocols. Also, this one may be radio sometimes. But all the others, anyway, radio, not radio, they are passing in points and on channel that could be attacked for sniffing or for denial of service or for other purpose. And so the protection and the channel protection and the protection of data in the communication and in the storage is a must. Also for preserving privacy. There is a GDPR at the level of the European Commission that was defined in the 2016, and the 2018 has been put in place. And in May 2018, the European Commission said, okay, all the web and other application have to be compliant with the GDPR, has to respect the privacy by design. So correctness, transparency, security, integrity, privacy, auditing with the possibility for the user to verify what has been done with the data, or the possibility to revoke the access to some data, or even the possibility to delete all my data that, for instance, Google or Facebook has collected by my activity. And this is a complex technical requirements, because constrained a lot of company to rethink to their process, not to the full stack, to the end-to-end stack, but also the stack for managing the data inside. This is an action of transparency, is a way to be more to be safer. But anyway, there are some margin for collecting data for research purpose, or collecting data for security or national security stuff, or for there are some cases in which the data are used, but what is absolutely relevant is that the user can have the evidence in any detail on how this data has been used and by who. So it is also possibilities, according to the GDPR, to publish by the single owner of the data to decide to publish some of his data. And this can be done anonymously. That means that the platform should have the possibilities to anonymize the data, to fully anonymize the data in a not reversible ways. And so there are a number of mechanisms and guidelines to verify how if a platform is GDPR compliant or not. We passed this kind of activity it was one of the first complex platform to pass this assessment in the 2019. And the assessment is complex because it's not only based on the user interface, so verifying if you have a senior consent, if you provide a number of features in your interface. I am not going in details, but also you have to allow the data, the source code inspection to permit the reviewer to see if what you have done, how you have secured the authentication, how your data are collected and coded, if they are encrypted, and so on. And there are also a number of tools like such as those for doing some penetration tests, for assessing the security for your front end. So there is a good paper on this that you can access on IEEE access. So on top of this aspect, there is the needs of having a living lab support. A living lab means from one side to have the support for developer that should be trained from beginners to skilled people, but also with the possibilities, I am getting faster to be sure to arrive at the end in time, but to have also a sort of life cycle in which you can develop all the aspects, from connecting devices, connecting external service, ingesting and developing data analytics, providing this information to API or microservices on the web, and producing application and dashboard, and up to hand to create the community, so to set up the living labs. So this life cycle involve a lot of activity that are reported here in the circle, and you may engage a number of operators and a number of groups and stakeholders of the city in this process to create a community around the smart city or around the living lab for IoT development in general. So this means that in this case, the development life cycle is quite different with respect to the classical software engineering life cycle, because we have data analytics, and we have not only analysis, design, development, test that are the typical workflow or waterfall flow or other spiral life cycle, but there is also data ingestion, data selection and ingestion. So the life cycle has to be completely revised. We have defined a new life cycle, and so you have actually focus the analysis on this aspect, because these aspects are very innovative with respect to what is the classical development life cycle of ICT, because you have a data discovery, data ingestion process, data analytics development, a special tool development, and these aspects are very far from the mentality of the ICT or software engineer. Are more oriented on data engineering, but the data engineering and software engineer have to work together in this kind of complex infrastructure. So from the architectural level, so now it's clear that how all the things that the infrastructure that you have in place should communicate with the infrastructure, with the data infrastructure in some way. In most cases, through brokers or through adapters developed as a data flow or as a workflow. And when you have the data, you can make algorithms for prediction, anomaly detection, environmental model, 3D model, simulation, or many analytics, obviously following some life cycle. And the results of the analytics can be visualized on some, needs to be visualized and rendered in an easy manner on some dashboards, and the Living Lab support you and all the developer in acting on different levels. So the user of the Living Lab, the developer, can create their own adapters for data ingestion, can collect their data, can develop analytics, can develop the dashboard, and so on. So this is more or less the same. Just to remark that technically there are a lot of channels that needs to be activated, not only IoT and brokers, but also Industry 4.0, social media, geographic information system, because the city have that kind of information in place. So almost all cities, they have their geographic information system. They have a number of legacy and external services, and also the user have their personal data that could be used inside the platform. So the more technically, the platform would like to have some visualization, and the visualization may be interactive. So that means that you need to interact with the process, and so to send commands from the user interface to the process, and maybe with the aim of selecting different data, but also selecting some data transformation. This is a way to make some business intelligence tools. So business intelligence tools are the first way to make some decision support. And business intelligence tools also may request some data analytics, or may request some workflow. So to send people on the field to make some maintenance in your plant, or to do other things like that. While all the rest, so brokers, and data obviously are at the disposal of this functional aspect. But the IoT apps, so the functional and the data flow and workflow are the logic of this kind of large application. This is a technical representation of what we use. For instance, for data ingestion, we use an Node-RED that is an open source. For storage, semantic storage, we use the Virtuoso RDF storage, or for time series open search, and then on top some API for federating also other platform and for providing data and information through the visual interface. Horizontally, you need authentication, authorization, process management, data expression, GDPR, and all the other things that are needed. And they have a pervasive impact on all the other tools. So this is very technical. Is a stack with all the components, and you see the open search and NIFI for internal broker. In many cases, you see the usage of Node-RED that guarantee the external interoperability, the internal interoperability, and also the data collection. This means that you use the same visual language and Node.js internally for interacting with the external, and also for the data transcoding if the data are not arriving directly from the device to the storage. So I understand that it's complex, and there are many different open source like GeoServer or Beam Server or OpenMind or CCAN and other components that can be used as a microservices in this large application. So you may have also IoT Edge solution in which you need to have some some IoT app in Node.js, Node-RED, and this could be in Raspberry or Linux or whatever, installed installed on-premise, so in the field, and this small IoT Edge device can communicate with many channels or internet or Modbus or other, so radio or non-radio communication with the many devices that you have in the field. The field could be the industry in this case, but could be also for the home. This kind of edge can communicate with the cloud part and with the dashboard with some secure communication, obviously, and you need also to make maintenance of this activity. So you can connect this architecture with some connection through the federation in terms of smart city APIs. And this communication again is protected, and again is passing through as a REST API from one node to all the other nodes. It's a way to distribute the effort. It's a way to connect different geographic area without having a centralized solution. So you can have multiple services connected together, and each of them can be responsible for each data and can decide which data can be shared with the others if they like, or can create something completely independent as well. So smart application on top is another aspect. What is going to be a smart application in this context? So the interface are dashboard, and behind dashboard some IoT app that are Node.js. And so you have the possibilities to close the loop and change the user interface and interact to implement the business logic inside the IoT app. but it's not enough. Sometimes you need data analytics for instance, for smart parking, you need data analytics for parking forecast. For smart waste, you need data analytics for optimizing path or deciding when your truck should collect the waste. Or for smart irrigation, you need to decide when it is the best moment to turn the water on or to save the water for the next days, according to the weather forecast, for instance. And the data analytics can be distributed as well. So you can have some data analytics on cloud and some business logic for logic in cloud or in edge. In edge means that you have those in the field, directly connected to the broker. This also means that you may close the loop from your application directly in the field and communicate with the cloud only when it's needed or only for communicating the decision that have been taken at a low level or for communicating parameters, for instance. So smart applications are a complex network of relationship. This is an example of a small ontology for representing the relationship from dashboards and the widgets inside the dashboard and IoT application and data. Data could be of different kinds. They can be devices, point of interest, KPIs. You may have data analytics also that can be, for instance, created and managed by the IoT application, which produce other data, and the other data are located in some place and feed in the knowledge base. So if you have a knowledge base, you can make semantic queries in your set of applications to understand how they are related to each other and to understand the problems that you may experience on this. And you can also shortening the time for maintaining, because a single data in a complex city may impact on a number of applications. For instance, the weather forecast could be used for traffic flow, but also for predicting parking, could be used for predicting bike sharing, for predicting revenue in some shops, or for predicting the right time in which you can see more people in the garden. And so you need to clean the garden more often if you have more people. And so there are some data that are really exploited by many smart applications. And so there are tools like this linked open graph that could be used for navigating in this kind of structure. And you can query with the Sparkle, for instance, with the Sparkle, with the semantic query language to understand what is going on and to understand if you have to do a maintenance of a given device, which kind of application are impacted by this device. You are not anymore in a pillars case, so in which you have all applications separate, and so you need to have to understand who has to be informed if you are going to replace some device with a new one, or if you are going to just to make a maintenance on some smart application that produce, for instance, heat map or forecast, and this forecast could impact in many other applications as well. So behind this kind of solution, there are, this is a view of Node-RED. Node-RED is an interface to produce a Node.js process, all open source on the basis of visual programming. We have developed a large library, in effect 3 large libraries, for scripting and creating Node-RED programs in the context of smart city. They are, I think, more than 150 different blocks that allow you to compound to query your complex application, such as to ask when will be the next bus arriving, which is the status of a parking, which kind of routing could be better for me if I would like to avoid a pollutant area, how much time I could get to go from one part or the other of the city, what is going to happen in a certain part, or to activate to have some suggestion from the social media, or directly to interact with the dashboard. So you can script almost all. Why to script this? Because this is a very easy way to create your data ingestion and data transformation. In some of those blocks, you can insert JavaScript code, or you can even call some data analytics in RStudio or Python, for instance. But the work of creating these additional microservices or complex data transformation could be dedicated. You may have some dedicated personnel for developing new microservices without the needs of involving programmers or very skilled programmers in the scripting on the logic, for instance, or in adapting the data flow for new needs. Because in the large application, such as in large industry or in the city, it is quite often that you need to adapt what you have to new sensor, or to some changes in the version of the sensor, or to create a new data analytics or a new user interface. So data analytics, I have prepared for you some example. I am not reading this slide. This is almost the full set of data analysis that we do. I am providing you some example. This is an example in mobility and transport. Most of the data analytics are related to the reconstruction of flow, traffic flow, to understand how the machine and cars and vehicles move, and to forecast. In most cases, the data came only from the sensor on the field that are scattered in the city. While you need data that is dense, you need to reconstruct the traffic and to understand how the traffic is moving every city segment. And this can be done with the algorithm that are typically called of traffic flow reconstruction. They can be created from different kinds of sources. Google do that from Google Map. We do that from sensor. Others do that from box in the insurance of the insurance that they put in the cars, and so on. So this information regarding traffic flow can be used for predicting traffic flow, for predicting slots in the parking, to understand how bike racks are used, and also to classify, for instance, travel means, how the user move in the city, which kind of needs they have. If you know how they move and which are their needs, you can actually do a better job if you are a decision maker in the city. If you can decide to change the structure of the city in a way that you have less crowded condition during the day, as we see here in red. So other example are smart parking. This is quite straightforward. So AI can be used for parking prediction, to understand when could be more for you more probable to have parking, a free slot in when you start from the house. Maybe you take 45 minutes to arrive at the parking, and you can know in advance where to park. When you could be confident that a parking lot for you will be available. In some cases, you can book the parking, but the parking booking is quite not common, not yet common. Again, for bike sharing, you can have a floating sharing, or you can have a bike rack. If you have an electric vehicle, typically they are in bike rack. So for recharging them. Again, you may have some predictions. You may use data analytics for anomaly detection to understand if you have some inception of critical traffic conditions, or critical number of people in a part that may be curious of something that has been happened there, and so you need maybe to serve the critical case. You don't have an accident, but maybe there is a cut on some trees that has to be saved, for instance, or there is a pipe that broken a pipe and you have a flooding of water in middle of the street that create a problem. It's not a traffic accident, but it's something happening in the city. So this is the same of traffic before. And this is a traffic flow reconstruction. You see, this is a very complex stuff. And we do that for several cities in Europe. And the traffic flow reconstruction can also be used to understand how the pollutant penetrate in the city, because the traffic is one of the major sources for NO2, for instance, or CO2, and the wind can push this NO2 in a direction or in another in the city. And so to forecast this information can help you to understand where it's safer to walk, when it's safer to make a gym, when is the best place to bring the baby to take a good air, to play in the garden, which is the best garden in which you would like to bring your son. Another activity could be on predicting landslides, very complex, to collect land information like how the land is, the slope of the land, the kind of the land, but also how much rain has been arrived in the previous day, or which the amount of humidity accumulated, and so on. This also allowed us to make prediction on the risk of landslides, and this has been applied in the province of Florence. Now we are porting this at the level of the whole Tuscany. And in this case, we use also explainable AI, so artificial intelligence with the specific explainable tools for explain why a certain level of risk has been estimated by the artificial intelligence algorithm. So to explain why the risk has been so high according to the AI, and so the decision maker cannot have only a red alarm said, okay, there is an alarm, you risk to have a landslide in this part of the area, but there is also an explanation. So there is a high risk because you had the high water raining in the previous days, and the slope and the matter of that part is particularly risky, because now this kind of prediction model are not in place. The risk map for landsliding is something static, not real time. We estimate every day a new estimation with a high probability and a high precision. We had also done some tools for computing CO2 inside the city. Also in this case, in most cases, the estimation of CO2 is just performed at the level of the whole city, which is the amount of CO2 produced by the cars in the city. You count the cars entering and exiting in the city every day. You make an average according to which kind of vehicle you have, if you have so 30% of truck, 40% of the gasoline and other. So you make some rough estimation, but you don't know where is the problem, where are the area in which the highest level of CO2 are created. And for the healthiness of your population and for your baby or for the ancient guys is your grandmother or grandfather, could be very useful to know where should go to work, or at which time they should be better to get out to take fresh air and not pollutant air. So this is the map for the accident density in Florence, just to understand which are the most critical parts. This is another map for understanding how many people are passing through specific area without recognizing them, just counting to understand where are the places to be cleaned, where are the most common area in which you have to go more often to clean the city, and by instant there is a problem in that part. You can know how many people are used there. I used to be there, and so you can send a rescue team for proportionate to the number of people that are in that area. Typically, and we estimate also origin destination matrices, so that allow you to understand how people move. So when they have been in a part of the city, where they go after, which are the paths that they do when they visit, for instance, Florence. Florence is a large city for tourists, and to know how tourists use the city is very relevant, not only for business but to serve them. So, and to make the population that live every day in the city in a condition to use the city, even if there are many tourists that in some measure could be not appreciated by the people who live there, because the tourists obviously are too many, and sometimes you need to inform and to understand where the tourists pass in a way that you should not be so crowded by tourists when the city user need to go in the city hall, for instance, for the normal practice or normal activity of a city user. And these are examples of usage. With the same color correspond the same behavior during the day. So this is another tool for classifying people, how people move. Or this is another tool for, always web tool, for analyzing the demand of mobility versus the offer of transportation. How much people would like to move from one part of the city to another. So the public transportation is always used by the city users, by the citizens. How many of city users are moving from some peripheral residential area to go in the center to work, or to go to work in another part of the city? At which time they move? How many buses they need? We should find a way to reduce the number of the critical condition, in which you have a crowded condition on buses, on bus segment, or you have a crowded condition on the bus stops. You need to understand this to improve the service, and to reduce in this period also to reduce the probability of infection, obviously. But we started develop this much earlier, actually. And social media is for the same purpose, to analyze the Twitter or and comments, also with the sentiment analysis, to understand if the quality of a certain service has been appreciated or not. It's Twitter. I am going faster because we are running out of time. So data analytics. Data analytics are, in most cases, are developed in Python or RStudio. And for what we use in Snap4City platform, the data analytics produce some container that can be used in the data flow that we call IoT app as a microservices. So you can ask to your data engineer to develop some data analytics and some intelligent data analytics, and this process can directly feed the results in the platform, and you can use these data analytics, these blocks, as a stream processing tools in the data flow. So dashboarding is the final end user aspects. Dashboard is a way, so sometimes when you ask one, I would like to have a dashboard. In most cases, they intend everything. So from the data to the visualization, because they don't have the perception of what I have presented so far. So the complexity of taking the data and aggregating them, multi-protocols, multi-formats, and bringing them and connecting them to each other and creating information, so hints with the data analytics at the hand, producing some prediction or fancy representation and so on. So most of the guy here, so the decision maker don't care. Don't care means that we have to inform them the complexity of this, but at the end they would like to have a pie or to have a bar series or a trend, and we need also to teach them how to read this kind of graph, because there are many kind of graphic representation that range from histograms, heat maps, geomaps, dynat, staked or box plot or radar or maps, whatever. Many different visual representation that could be very nice to have it. This is just an example, because here there are also some missing, like 3D shapes or beams or other complex representation. The role of a dashboard builder is to map the data coming from the original data and the resulting data coming from data analytics to widgets that can be used. These are the widgets that can be used to compound your dashboard piece by piece. So again, web application with a wizard in this case that allow to understand which kind of data can be matched, can be how, if you select a given data, how this given data can be visualized. And not all the data can be visualized in all the representation. And if you have a representation, not all the data can be used to have it, this kind of representation. So this matching from data to visual representation is something that you need a smart engine. This is what we have here. A smart engine for speed up this information. Otherwise, you need an expert. You need an expert of data visualization. You need an expert that knows exactly which data you have and which data structure of each data element. And this very complex activity. So at the end, the results could be something like that, in which you can have some maps with the heat maps, with the pins, and with the multi-series or bar series or stacked diagram or tables with colors, with heat map colors, and so many of this information to make a decision on how to make changes in the city or in the industry. In addition, you need to have event-driven. So most of the dashboard may not only have something to be visualized, but you need also to click here on the pump, on the wave valve to act on the system or to act on some business intelligence. You need to, for instance, you send an appreciation, or you make a reservation, or you click on a button. At the end, you may receive the status of your lights or the status of your commuter, of the red light. So you have an actual interface, an actual, let's say, event-driven interaction from the web pages to your servers. And the IoT application here are Node.js process running on the server side, while you have the user interface is on the client, on your web browser. And this communication has to be in a secure ways managed. So for instance, a WebSocket secure, HTTPS, but if you would like to have event-driven, you have to go in a WebSocket. So these are other examples. And if you would like to script, so to allow your designer to create your application, even creating the business logic from what you hacked in the dashboard and what you see in the dashboard and what you interact with the rest of the platform, you need to have a counterpart of your graphic widget inside the data flow, as there are many examples here. So again, there are many interactions from the dashboard to the element that you have. Some of them are directly through the APIs or to the database back and forward, but also through the IoT app. So the decision support is complex, and when you are going to make some decision at the end, you answer to some questions. No? For instance, which kind of answer you need to answer? Which kind of questions you need to answer? For instance, you would like to respond what is going to happen in the future? No, you don't need only historical data. What is going to happen, because you need also some predictions. And so according to the question that you do, you may need different tools inside your system. For instance, I have here something include my part. So if you would like to go, you would like to answer what is going to happen here, you need the special tools, at least with the prediction. If you have even some, if you have some data analytics or simulation, you may have some possibilities to forecast. But when you need to answer what is going to happen if something could occur in the future, but you don't know in advance. For instance, what is going to happen if some gas or some pipe is going to broken in a part of the city and you don't know where the pipe is going to be broken? You have to be ready. You can simulate the broken pipe in every part of your city. It could be very, 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 very complex to make simulation in all parts of the city. So you have to be ready to react with the specific tools, and the tools have to be so far and so effective to give you support in real time with defining, producing an answer according to the scenarios that just occurred 10 minutes ago. So, 10 minutes ago. And so you need actually to have a number of tools that are, you need to address, for instance, historical data, real-time data. You make a short and very long-term prediction. You need also analytical model. You need to integrate a simulation model. So you need to integrate a lot of these tools together. So it's not enough to have a data analytics for making prediction if you would like to have an actual decision support system. In most cases, your decision maker is not only asking you, please make some simulation on how to change the traffic because we have broken a pipe there. They ask you which is the best solution to solve the problem. And you have to give me in half an hour or 2 hours. You cannot give me in 5 days because it's too late. Because in 5 days, all the city would be in trouble. There are 100,000 of people or millions of people that are moving there. And so in this complex way, you need to set up real-time tools for modeling scenarios, but also simulating the condition. And your long-term machine learning AI solution can be very effective and fast enough to make the prediction in a long term. Long term could be months, but long term could be even what is going to happen in 5 hours, because most of the prediction are work very well in 15 minutes or 1 hour. But what is going to happen in the next days? What is going to happen in the next week for long term also? And you need also criteria to decide if a solution and another solution, which is the best one. So you need to have a knowledge of the scenarios and of the event and the environment in which you do this kind of you implement this kind of solution. So I have some few examples very fast on application in smart city and also industry.
6 minutes.
Okay, I will do it in 5 minutes. So if you would like to know more, you can get them from this slide. So this is case of the smart city control room in Florence. There are one dashboard and many dashboards connected, even for the what if analysis. This is the nice view for the 3D shapes. Other views for the NOx shaping, as we have seen before. This I have commented before, is just a reminder. This is an analysis of people tracking with the thermal cameras. We don't recognize people. It's just for counting and to understand how people are moving in front of the City Hall of Florence. We also recognize the kind of people. So people or cart or babies or bikes, whatever. This is what we do with the mobile app for producing commented suggestion and engagement to the users. Smart parking. This is a smart light in Sweden. This is a national service for estimating 15-minute city index, in this case in Bologna, but it's active with the NLX for the whole Italy. This is an example of real-time chemical plant. They have our system for controlling the plant. We do that maintenance, business intelligence, and also decision support for deciding which is the best production process for the next days, and with the synoptics and dashboards. This is the implementation. So again, IoT hub for collecting data, some IoT hub for managing data analytics, for planning and for prediction, and dashboards on which the user can interact and change the setup and taking decision on what is going on to happen in the next, if you have a damage, if you have a problem in a part of the plant, and so on. Some views, examples in the flows, control room, integration of workflow and data flow for maintenance. And this is the details, how we manage predictive maintenance and predictive training and digital twins. So this is the 3D representation of the plant. If something happened, it's possible to understand which part of the plant has been in trouble and to send them the team. The system can also block a part of the plant and close the critical flows that could. So this is particular critical because this kind of chemical plant also produce acid chlorhydric or other things that are not nice to be breathed by human. Other chemical plant for production of rubber, and that's it. So thank you. If you would like to have more, you can go here in this page with a lot of training course and slides. And this is our path. So it's an occasion to say thanks to all the partners that we have collaborated. There is also a possibility to download this document and also document regarding fireware. Thank you.